Everyone, Phúc Thăng here. Today I will explain you what is DNA replication. DNA replication is maybe I will explain it by my thing of myself. It, you have a one DNA and the DNA replication is separate of the one DNA to one strand here and make a new DNA. To make a new DNA, we have a helicase. We have to separate the DNA. Yeah. And here to make a DNA, we need to DNA polymer to help them to do that. And yeah, and the DNA. And when we finish one strand in here, and then we go there to make a more DNA, and go there to make a more DNA, and when they finish, we to there, which will have over two separate DNA. And how to make, and here we call it Okazaki fragment. Here is Okazaki fragment, and the half of the Okazaki fragment is ligand. The ligand have stick the old DNA, one strand separate DNA to the new DNA. It's Okazaki fragment.
Hey everybody, so we're talking about DNA replication, like Phúc Thăng said, and so I'm going to give you a little more information. So after a helicase unzips the two strands of DNA nucleotides, an enzyme called topoisomerase comes right here in front of the helicase and helps to keep these two strands loose. Keeps them from supercoiling because they get really tight, a lot of tension builds up right here. So topoisomerase keeps them loose so helicase can unzip them more easily. Yeah. And then after they've been unzipped, single-stranded binding proteins come and they attach to the nucleotides to keep them from coming back together. Because the nucleotides naturally want to keep together. Yeah. So you separate them with SSB proteins. Yeah. And then you see we have DNA polymerase, and there are two strands now. So we talk about this as being the leading strand, and this as being the lagging strand. So the leading strand can go forever. As helicase unzips more DNA, this leading strand can just add new DNA nucleotides forever. But this can only do it in little small chunks. Then it has to go back and do another chunk because it's running in the opposite direction. So when it's made a chunk, which we call Okazaki fragments, then primase will come and add a little piece of RNA as a marker. And DNA polymerase will come right to that marker and then make another strand. And so you have now two Okazaki fragments. And then eventually ligase will come and add some glue, adhesive stuff, and it will bond the two Okazaki fragments together. And then you also, so you'll have the two leading strand and lagging strand. And then the leading strand runs from the 5' end to the 3' end. This parent strand, because it's the old strand, we call it the parent strand, runs from the 5' end to the 3' end. And that means basically that the first sugar, the first nucleotide, the sugar of the first nucleotide bonds with the 5th carbon to the 3rd carbon. 5th carbon to the 3rd carbon on the sugar, 5th carbon to the 3rd carbon. And then on the lagging strand, this other parent strand, it runs from the 5' end to the 3rd end this way. So it runs from the 5th carbon on the sugar, bonds to the 3rd carbon on the sugar. So they're anti-parallel, running in opposite directions. It's like a two-way street. And then after they've made the two strands, these are the new DNA nucleotides, then you're gonna have two new strands of DNA eventually. After everything's been unzipped and all the new DNA nucleotides have been added. Of course, DNA polymerase is faster. And this DNA polymerase is faster because this is the lagging strand, and it has to run this way, and go back and run this way, go back and run this way. And this one always just goes forward. So they're kind of like that. And then you're done, you have them all together, and you have two new strands of semi-conservative DNA, which means there's an old strand in each and a new strand of nucleotides in each. And remember we talked about how an enzyme would put an RNA marker on the DNA strand so that the DNA polymerase on the lagging strand knows where to start the next chunk? After the new DNA has been made, an enzyme called exonuclease will come and it will take the RNA marker off, and then DNA polymerase will put new DNA in place of it. So that's very important, and I just wanted you to know. Thank you.